In this video tutorial, I will talk about processes that take a long time to execute. In many applications, users may start processes that take a while to execute, 5 minutes, 10 minutes, or longer. Often such processes read and process existing records from the database. If there are many such records, and/or if processing of every record takes a long time, the process may take a while to complete. So how do we deal with such situations in ORAM? By default, ORAM performs the entire process within a context of a single database transaction and only commits the transaction at the end of the process. If the process takes a long time to execute, this may seriously degrade performance of the system in the multi-user mode. A database transaction locks tables used in the transaction, so if another user needs to access the same tables, he will have to wait until the transaction is committed. This means that the process must commit the transaction every now and then. If the process reads and processes records, for example, the process must commit the transaction every time a certain number of records has been processed, 1 or 5 or 20, depending on how long it takes to process each record. Let's look at an example, and I will show you how this can be done. So here I have a process called handle records. The process is started by the user and it reads all records of the object A and then processes each record in a sub-process called handle record. Let's ignore the second rule for the time being. Each record takes about 5 seconds to process. This is achieved by using the plugin which just sleeps for 5 seconds, so I am cheating here. Let's ignore other rules here. I only have 5 records of the object A here, so the entire process takes about 25 seconds. So to get ORAM to commit a transaction every now and then, I will either need to commit the transaction explicitly by using the commit transaction action, or use the in-batches key of the find action. Here we're using the commit transaction action, committing a transaction after every record. An alternative is to go to the parent process and change the find action to use in batches of. So by using commit transaction or in batches, we make sure that the system regularly commits the transaction and allows other users to access the data while the long process is running. When a user runs such a process, he will see an hourglass cursor and he won't be able to do anything else while the process is running. If the process takes a really long time to execute, this can be a problem, as the user will have to wait for a long time without being able to do anything. This can be addressed by forcing the process to run in the background. When the process runs in the background, the user doesn't have to wait for the process to complete, and he can do other things with the system. He will be notified in the status bar every now and then about the progress of the process, and he will also be notified when the process is completed. To force the process to run in the background, we need to use the run in the background property of the process. And there we specify the number of seconds after which the process will switch to the background mode. Note that we have to specify this value only for processes that are explicitly started by the user, and not those that are started by other processes. So in our case, we specify this property for the handle records process, not the handle record process. We also need to calculate and report the progress of the process. The progress will be reported to the user every time the transaction is committed, so we need to report the process before the commit transaction is called. To do this, we can use the set progress action. This action has two parameters: mandatory value of the progress in percents and an optional string that will be displayed to the user. In our case, we want to display that we are handling record number X out of the total Y. The total number of records found, as well as the number of the current record, can be stored in the session object, for example. So here we have the session object. If we look at its persistence, we can see that it is marked as stored session values. And we have two attributes: current number of the record and the total number of records. We initialize the values here and increase the current number here. And then we use the set progress action to report the progress to the user. Let's see how this works. So I log into the application and I run the handle records process. In approximately 3 seconds, the process will go into the background mode, and I get a message about it. And after that, the progress of the process will be reported in the status bar. And then when the process has been completed, there is a notification message about it.